You probably don't know this, but the very first molecule that ever existed in the universe was something called helium hydride ion, or HEH+. Sounds super nerdy, right? But this tiny, invisible ion is actually the first heartbeat of chemistry in our universe. And just recently, scientists in the US managed to bring it back to life, rewriting how we think the universe began. Picture this. It's 13.8 billion years ago. The Big Bang has just happened. Everything is a swirling soup of blazing plasma, hotter than you can imagine. No stars, no planets, not even atoms as we know them. Just chaos. Then the universe starts to cool down a little. Helium atoms form first. But helium is a loner. It doesn't like bonding with anything. It's the introvert of the periodic table. But out of nowhere, a brave little hydrogen ion, basically just a proton, comes flying toward it. And boom, the first cosmic handshake happens. Helium meets hydrogen. They form HEH+, the first molecule in the history of the universe. That single bond changed everything. It showed that atoms could connect, that chemistry was possible. And once HEH+ appeared, it started reacting with hydrogen atoms to form H2 molecules, the same hydrogen gas that cools down space clouds and helps stars form. In a way, HEH+ is the ancestor of all stars. Without it, the universe might have stayed too hot and chaotic for stars to ever ignite. But here's the weird part. Even though scientists have known about HEH+ theoretically for decades, they could never actually find it. Why? Because this thing is ridiculously fragile. It can only exist under extreme conditions, the kind of environment you get inside stars, not on Earth. In labs, when scientists create HEH+, it barely survives for a few millionths of a second before falling apart. It's like a ghost molecule. There one moment, gone the next. Then, in 2019, astronomers finally spotted it for real. Using the SOFIA telescope, a telescope on a jet airplane, they detected HEH+ in a distant nebula called NGC 7027, about 3,000 light-years away. That moment made headlines. After 13 billion years, we finally saw the universe's first molecule again. But the story didn't stop there. Recently, American scientists went even further. They recreated the chemistry of the early universe in a lab. They cooled hydrogen and helium gas to near absolute zero, replicating the conditions right after the Big Bang. Then they measured how HEH+ reacts with hydrogen. And here's the crazy part. They discovered HEH+ is way more reactive than anyone thought. Old theories said that when things get that cold, chemical reactions basically freeze. Nothing should move. But in these experiments, HEH+ was still dancing, still reacting like it had a spark of energy left from the birth of the cosmos. That means early universe chemistry was probably much livelier than our models suggested. This changes a lot, because HEH+ reactions affect how quickly gas clouds cooled, and that determines when the first stars could form. So if HEH+ was more active, the timeline of star and galaxy formation might need to be rewritten. That's why this tiny ion is making such big waves in science. It reshapes our story of how everything began. Now, you might be wondering, cool story, but does HEH+ have any practical use on Earth? Honestly, nope. You won't find it in perfume, rocket fuel, or your phone battery. It's way too unstable to survive outside a lab. But its value isn't practical. It's fundamental. It's the key to understanding the first chemistry that ever happened. Through HEH+, we can rewind the clock of the universe, peek into the very moment atoms first learned how to bond. It also helps scientists model plasma, fusion reactors, and even stellar atmospheres, because it behaves the same way matter behaves under extreme conditions. It's a bridge between theory and reality, between what we can calculate and what actually happens in nature. And the reason people in the US are talking about it so much lately? Because this new research challenges old science. It proves that even the simplest assumptions, like colder means slower reactions, can be wrong when you're dealing with the universe's first chemistry. This is what makes science beautiful. It never stops correcting itself, never stops evolving. Think about it. A molecule born 13 billion years ago is still teaching us new things today. That's kind of poetic, isn't it? So next time you look up at the night sky, remember this. Every shining star you see exists because of one tiny spark. The first chemical bond ever formed. HEH plus was that spark. The first molecule. The first whisper of order in a universe of chaos. It's the moment when the universe stopped exploding and started building. And that's the story of HEH+, the molecule that started it all. If you love stories that make the universe feel simple and magical, hit that like button, drop a comment, and tell me what other weird but true space stories you want next. Because sometimes, the smallest particle carries the biggest story.